Before we begin, take a moment to get comfortable. Let your arms go heavy, your breath slow. And as you listen, feel free to leave a comment sharing what time it is, where you are, and what city or village you're listening from. It's love to know. And if you'd like more quiet stories like this one, don't forget to subscribe so they gently appear when you need them most. Now, let's begin. It begins in stillness. You're walking across a wide, open field. The grass moves gently in the wind, but the land beneath your feet feels permanent. Soil gives slightly under your weight, but the ground itself, the deep rock, the hidden layers, they feel like they've always been there, unmoving, unbothered, asleep. This is how most of the earth feels to you. Stable, reliable, comforting, and yet, somewhere far beneath the quiet plain, stone presses into stone. Not violently, not yet, just gently, gradually, waiting. There's a kind of sleep the earth falls into, not a sleep of peace, but a sleep of forgetting how to move. This chapter is about that kind of stillness. You might picture earthquakes as sudden rips in the world, violent, noisy, terrifying, and that's true when they come. But most earthquakes don't begin with noise. They begin with waiting, with centuries of silence. Some faults move constantly slipping, bit by bit, relieving tension with soft tremors or visible cracks. But others, they do not move. They hold. They hold for so long that people forget they're even there. Homes are built. Roads are paved. Generations pass, and then, one day sometimes, after 300 years, the land remembers something it had forgotten. In the central United States, far from the edge of tectonic plates, a system of faults runs beneath fields, forests, towns. They are not dramatic faults. You won't find cliffs or steaming vents. You won't hear rumbling beneath your feet. But that is the very thing that makes them dangerous. This part of the earth sleeps deeply. A case and deep sleep builds deep pressure under the farmland. Beneath the winding rivers in old brick towns, layers of crust have been pushing against each other invisibly for lifetimes, not out of anger, it's just out of inevitability. It is in this kind of quiet, this deep, unchanging quiet, that the biggest surprises begin. The rocks do not protest, they simply hold tension, like a bowstring stretched gently over time, more and more, until it slips. But before it does, you get nothing. No warning sirens, no rumble. It's just a continued illusion of stillness. Stillness that stretches decades. Stillness that builds hope. Hope that this place is safe. But the earth does not promise safety. It only offers patterns, and this pattern is one of sleep. Then sudden waking. The last time the central U.S. woke up this way, it was 1811. People living in the Mississippi Valley heard strange booms in the distance. Then the ground rippled like waves on a pond. In Missouri, chimneys toppled. In Kentucky, riverbanks collapsed. Church bells rang in Boston. The earth didn't just shake, shifted, and then it went quiet again, so quiet that most forgot. But the ground did not forget. What do you call a danger that hides inside stillness? What do you call a rhythm that moves once every few hundred years? You call it deep sleep, not because it's safe, but because it's easy to believe nothing is happening. And so, tonight, as you lie in your bed, know that beneath your floorboards, beneath your yard, beneath the forests and highways, the earth may be sleeping. But even in sleep, it moves. It moves so slowly, you cannot feel it. But slowly is not the same as never. It breathes in inches. It stretches over centuries. It remembers, and someday it may wake again, but not with warning. Only with release. So you close your eyes and imagine that field again, wide, peaceful, unmoving, and far below it, a sleeping world stirs gently in its bed of stone, waiting. You walk across a prairie. The grass is soft beneath your feet. The sky stretches above you in its endless blue, and the wind curls around you without urgency. The world feels open, quiet, and steady. But just a few miles below the surface, where light cannot reach, the earth keeps its own hidden record. A record written not in ink, but in fractures, in bends, in scars of stone. And though you cannot see them, those scars are still there, waiting. If you could peel back the layers of the ground beneath your feet, as if lifting a page from a book, you'd see something strange. Not chaos, but order with imperfections. You'd see layers of sediment, each one formed over thousands or millions of years. Some are smooth, others are broken, tilted, shifted, folded like cloth. Those folds and breaks are messages, quiet ones, sent by the earth itself to remind anyone willing to listen that the past is not gone. It simply lives deeper now. The cracks beneath these calm fields are not dramatic. They are not like the San Andreas Fault, famous, exposed, visibly torn. No, these cracks are hidden, buried, subtle. They do not scream, okay? They hum. They hum in frequencies too low for your ears, okay? They hum in movements too slow for your body. But they move. They have names. These hidden faults, the Real Foot Fault, the Commerce Fault, the New Madrid seismic zone. But even their names are mostly unknown to those who live above them. They exist in research papers, in core samples and GPS data, okay? In the quiet minds of geologists who spend their lives listening for the next small breath from something very old and very large. Think of a sheet of paper, strong, flat, perfectly smooth. Now, imagine folding that paper once, and then again, and again. Each fold is a fault. Each crease is a record of stress, of pressure, of some distant force that bent what was once still. Now replace that paper with the Earth's crust, and those folds become stone. Not inches thick, but miles. And they go on for hundreds of miles in every direction. Even beneath the most ordinary towns. Even beneath your feet. People, don't think of the central U.S. as earthquake country. There are no mountains being pushed skyward. There are no volcanoes to warn us. The land is flat, friendly, predictable. But that's exactly what makes it deceptive. The earth doesn't need to be loud to be dangerous. It only needs to be patient. And the faults in this region have been patient for hundreds of years. They lie beneath soybean fields, beneath cotton farms, beneath gravel roads and winding rivers. They lie beneath churches and schools and family homes, not because they are cruel, but because they were there first. They were here before the first railroads, before the first farms, before the first people, okay? And they will be here long after. Some of these faults are mapped, some are not. Some are guessed at by reading the way groundwater moves. Others are revealed only after a quiet quake twists a fence line just enough to catch someone's attention. And when those faults shift, they do so in silence. You might not even know it happened. A painting tilts slightly on your wall. A window no longer opens as easily. A cabinet creaks at night. Tiny movements, whispers of rearrangement. The ground settling into a slightly different shape. You see, the earth doesn't think in days. It doesn't mark time with clocks or calendars. It moves when it must, and rests when it can. But even in rest, it is listening. Even in silence, it remembers. These faults, these cracks beneath calm fields, are like the creases in your palm. They don't tell the future, but they speak of use, of where, of a life already lived. They tell us something simple. What has moved before may move again. You might be wondering why these faults are here, so far from the edges of tectonic plates. The truth is, no one is completely sure. But one theory whispers of an ancient wound. Hundreds of millions of years ago, this region nearly split apart. A massive rift tried to open a failed attempt to tear the continent in two. The rift never completed. The earth held itself together. But in doing so, it left behind deep scars. And those scars, those ancient fault lines, still hold stress, still shift, still speak, even if softly. You may not hear them, you may never feel a quake, but the earth is not still. It is simply quiet, like the surface of a lake, calm and undisturbed, until a single ripple reveals just how much lies beneath. The next time you stand on solid ground, remember this: solid is not the same as still, and silence is not the same as safety. The earth does not promise you stillness, only movement, eventually. But even so, you can walk across those fields. You can live in that silence. You can rest, because the earth's slowness is also a gift. It gives you time. It gives you decades of calm, even as it quietly reshapes itself beneath you. Tonight, the cracks beneath your world are still sleeping. They do not reach for you. They do not stir. But far beneath the soil, the earth is stretching so slowly, so softly, that it feels like a dream, a deep geological dream that never ends in a single night. And in that dream, we build our homes, plant our seeds, and trust the ground beneath us. Until one day, the cracks remind us they are still there. Not as punishment, not as revenge, just as memory. Stone remembering. Stone, stone. You walk through a quiet field where the grass waves softly in the summer breeze. There's no warning, here no memory written in fire, but dig a little deeper, and the earth remembers things you do not. Beneath your feet, there are scars, old and buried, but not forgotten. Earthquakes, after all, are not just explosions of force. They are stories carved into the land, and the land tells them slowly. An earthquake begins with a whisper, a shift deep below, like a breath caught in the body of the world. But it ends with a trace, something visible, something tangible. It could be a tilted fence, a tree that leans unnaturally against the skyline, a river that curves too sharply, like it's trying to forget where it used to flow. These aren't just geological curiosities, they're memories etched in motion. Earthquakes leave behind changes so quiet you'd mistake them for natural evolution. But the earth does not evolve quickly. It remembers in jolts. Some of the most dramatic changes happen not in cities, but in farmlands and open plains. Places where no one is watching closely. A barn might lean a little to the left. A fence post might no longer meet its neighbor. A driveway might now crack right down the middle, as though the earth breathed out just once. And everything, man-made, shifted slightly from its alignment. But these changes don't come with a date stamp. That's the haunting part. You can't always tell when it happened. You only know that it did. And so, geologists, those patient keepers of the planet's memory, read these signs like detectives, piecing together the long-forgotten events that once shook the land. Sometimes, the clues lie deep within sediment layers, ripples of displaced earth beneath ancient riverbeds, where sand blows, where pressurized water burst through the soil during a quake centuries ago. Other times, they find subtle elevation changes in the land, detectable only by laser-mapped surveys from above to most eyes. It all looks like nothing, but the earth does not exaggerate. It leaves subtle footprints, and if you're quiet enough, long enough, they begin to form a pattern in the central United States. This pattern reappears with unnerving regularity beneath towns like New Madrid, Missouri, and far into surrounding areas. The earth bears old bruises. Here, more than 2 centuries ago, a series of violent quakes reshaped the landscape so dramatically that the Mississippi River momentarily flowed backward. Trees snapped in half. Chimneys fell as far away as Cincinnati. And the ground itself split open in ragged, uneven wounds. Today, you would barely notice. The river flows forward again. The fields have been plowed and planted. Towns have grown up and quieted down. But beneath that silence, the cracks remain. not just in memory, but in geology. It's easy to imagine earthquakes as events that come and go. A sudden jolt, then quiet. But in truth, earthquakes echo. Their effects ripple outward, not just through space, but through time. An old house that was slightly shifted during a quake in 1811 may develop uneven foundations decades later. A stream may cut a new path through a dip in the ground created by that long-past shake. A community might adapt without even knowing why, slowly adjusting to the new lay of the land, believing it was always that way. The remnants of earthquakes can also be psychological in some regions. Stories are passed down from generation to generation of shaking beds, of walls that cracked suddenly, of wells that dried up or turned muddy overnight. The details fade, distorted like old photographs, but the impression remains. Something powerful happened here long ago. These stories matter, okay? Because when memory lives only in stone, it takes great effort to hear it. But when memory lives in people, no matter how dimly, it becomes part of how we prepare in Alaska. For example, the 1964 Good Friday earthquake left deep scars not just in the terrain, but in how the state built its future. Communities redesigned buildings, schools practiced drills, seawalls and anchoring systems were strengthened. And today, even as time smooths the pain of that day, the lessons remain vivid in concrete and steel, but in quieter places where no one alive remembers the last big quake. Those preparations fade. Why reinforce a bridge in Indiana? Why worry about soil liquefaction in Tennessee? Why add earthquake retrofitting in Illinois? Because earthquakes leave behind more than just cracked roads and sagging porches. They leave behind opportunity. The opportunity to learn, to study, to map the story of tension and release, and to prepare not out of panic but respect. Respect for a planet that is always in motion. One of the most haunting features of earthquake aftermaths is the sand blow, a mound of pale sediment that erupts from the ground during a quake when water-saturated sand is pushed to the surface under intense pressure. To the casual observer, it looks like a patch of light-colored dirt, an odd hill in an otherwise flat field. But to a geologist, it is a loud signature of upheaval in parts of Missouri, Arkansas, and Kentucky. Thousands of these sand blows the landscape. Many were formed during the 1811 to 1812 New Madrid earthquakes. They are so common in some areas that farmers simply plow around them. But each one is a reminder of what the earth is capable of even in its most seemingly silent corners. Then there are the ghost forests. These are stands of trees that were drowned when the land suddenly dropped or water surged inland during a quake. The trees die, standing eerily still, their trunks slowly bleaching in the sun. Ghost forests remain as skeletal memories, silent testimonies to a moment when the ground moved, and the rules of the landscape changed without warning. They are often found near coastlines, like those in the Pacific Northwest, where the Cascadia subduction zone once unleashed a massive earthquake in the year 1700. That quake was so powerful, it generated a tsunami that traveled across the ocean and struck Japan, where it was recorded in historical documents as an orphan wave 1 with no apparent source. It took centuries for scientists to link that tsunami back to a quake on the North American coast, because even across oceans, the Earth remembers. Today, we use high-resolution satellite imagery, GPS sensors, to deep borehole instruments to track land movement with incredible precision. We can measure a shift of a few millimeters. We can detect when land bulges, drops, or stretches. And yet, with all our tools, some of the clearest evidence still comes from the quiet clues. A misaligned cemetery, okay? Bridge abutment that no longer lines up with the road, okay? A hill that shouldn't be there. A fence that bends just enough to make you pause. If you look closely, You'll find these clues almost everywhere. The earth is full of stories it's tried to bury, but the ground can never truly forget. As the sun dips lower and shadows lengthen over the calm plains, you may find yourself listening more closely to the hush, not because it warns you, but because it holds the memories of things that once reshaped the land. And in that silence, the next chapter begins, not in sudden noise, but in the slow tension beneath your feet, where pressure moves quietly toward release. Even now, the ground beneath the Mississippi River does not rumble often. It rests, it breathes, and it hums in low tones most people never hear. But once long ago it roared, and it did so not in the mountains of California or the cliffs of the Pacific Northwest, but in the wide, flat middle of America, in the heart of Missouri, a place called New Madrid. New Madrid is not a city known for drama. It rests quietly in the southeastern corner of Missouri, near the soft bend of the Mississippi River. Today, it is still and calm, surrounded by fields, forests, in a slow-moving current of time. There are no obvious signs of danger, no towering cliffs, no smoking mountains, no boiling springs. Yet, in the winter of 1811 and early months of 1812, it became the epicenter of one of the most powerful seismic events ever recorded in North America. It's a story both known and forgotten, revered by geologists, but passed over by most because the silence returned too soon. The New Madrid earthquakes weren't a single event. They came in waves, at least 3 major quakes and thousands of aftershocks between December 1811 and February 1812. The first struck in the early hours of the morning, just after 2 a.m., waking settlers in their wooden homes, shaking riverboats from their moorings, and cracking the earth like dry paper. The ground rose and fell like the chest of a great beast. Trees snapped mid-trunk. New lakes formed where none had been. And, most famously, for a moment the Mississippi River flowed backward. Witnesses reported a strange roaring from the ground itself, as though the earth had opened its throat and bellowed. But no one could quite explain what they were seeing. There were no scientific seismographs then, no emergency broadcasts, no plates on walls falling to mark the magnitude. But the reach of the quake was astonishing. Church bells rang as far away as Boston, sidewalks cracked in Charleston, chimneys tumbled in Cincinnati. It's hard to imagine today, rural town at the center of such a massive event. But the evidence remains in soil layers, in the stories of people who lived through it, and in the strange quiet that followed. Because once the shaking stopped, the silence returned. And it has lasted more than 200 years. But is the silence peaceful, or merely a breath being held? That's the mystery of New Madrid. Unlike faults in California or Alaska, where tectonic plates push visibly against each other, the New Madrid seismic zone sits in the middle of a tectonic plate. It's part of what's known as an intraplate fault, an ancient scar deep within the North American plate itself. It doesn't lie at the edge, where plates collide or slip past. It lies in the middle, hidden beneath sediment and soil, long assumed to be geologically calm. But calm is not the same as still. Some scientists believe the New Madrid quakes were aftershocks of ancient tectonic movements, echoes of something massive that occurred hundreds of millions of years ago when a failed rift began to tear the continent apart. That tear never finished, but the weakness remained, and that weakness sometimes shifts to the untrained eye. The New Madrid region seems too flat, too quiet, too settled to be dangerous. But dig down, and you'll find buried fault line zones where the rock has been fractured, bent, and slowly loaded with stress over unimaginable spans of time. The memory of the 1811 to 1812 earthquakes still lives in the region's shape. In places, the land has never returned to level. Reelfoot Lake in Tennessee was born from the sudden drop of the land during one of the quakes. Entire forests were submerged. The tops of trees still reach out from below its waters. Elsewhere, there are sand-blown mounds of pale earth where water and sand erupted from underground during seismic liquefaction. These features are still visible today, scattered across farmlands and hidden in woods, so subtle but unmistakable to those who know what to look for. And there is more beneath modern instruments, GPS sensors, satellite radar, and deep borehole. Seismometers have confirmed that the new Madrid seismic zone is still alive. The ground still shifts, ever so slightly. Fault lines still creep. Small tremors still occur with regularity. And yet, no major quake has followed in over 2 centuries. This puzzles scientists. Normally, after a major quake, a fault releases much of its built-up energy. But what if it didn't release it all? Or what if stress continues to build in subtle ways we don't fully understand? Could another major event be waiting in the wings? Some researchers believe so. They estimate that the region could experience another significant earthquake within the next several decades or centuries, not in our urgent human sense of soon, but in the slow geologic rhythm of the earth. Others argue that the fault is slowly dying, its energy dispersing harmlessly over time, that the 1811 to 1812 events were extraordinary but unlikely to be repeated, that the silence is final. But the earth is not obligated to answer us, and in the meantime, communities in the New Madrid region continue to build, grow, and live on top of these sleeping scars. Homes and schools stand atop old liquefaction zones. Bridges cross rivers that once reversed. Cities rise on soil that once rippled like waves on the sea. Preparedness here is a quiet affair. Some building codes reflect the possibility of seismic risk. Emergency management offices maintain earthquake drills. But in the absence of recent memory, awareness fades. Human time is short. The Earth's memory is long, and so the New Madrid. Mystery lingers, not just as a geological question, but as a metaphor. What other forces lie hidden beneath calm surfaces? What other systems, natural or personal, seem peaceful only because the last disruption is too far behind us? The truth is that not all history is visible. Some of it lives underground. Some of it waits, patient and slow, for just the right moment to move again. And when it does, we don't always recognize it for what it is. That's the deeper lesson of the New Madrid earthquakes. Not just that they happened, but that they happened in a place we still struggle to believe is dangerous. That they reshaped the landscape of an entire region and disappeared behind cornfields and quiet days in the quietest part of the U.S. The earth once changed everything in a matter of minutes. It might again, or it might never, but even in silence, the ground holds the memory, and sometimes that memory returns not as a shout, but as a slow unfolding, a soft realignment, breath held, then finally exhaled. Tonight, as you rest, picture the great river once moving backward. Picture the ground gently rising and falling. Picture the fences that no longer met, the wells that turned dark, the forest that drowned, and then let it go. Because the earth is quiet now, and in that quiet, the mystery sleeps again. There are no ticking clocks inside the earth, no alarms, no countdowns, just pressure quiet, invisible and unceasing. It doesn't announce itself. It doesn't ask for attention, but it is always there, deep beneath your feet. Entire slabs of the planet are on the move. They drift, collide, and twist ever so slowly, too slowly for a human to feel, too gradually for a single lifetime to notice. But that movement builds something. And what it builds, it stores. That something is stress. And stress, geologically speaking, is not dramatic. It is not a sudden event. It is a long, persistent accumulation of imbalance. A tension between what the earth wants to do and what it is not yet allowed to do. Like a bowstring pulled taut, or a breath held for too long. This is how earthquakes begin, not with violence, but with patience. You might walk across a meadow in the central U.S. and feel nothing. The ground is soft, the grass is quiet, a bird chirps, a tractor hums, but a few miles below, the crust may be aching under pressure. It's not enough to move yet. It's not enough to relax either. Pressure has no voice. It builds in silence, over centuries, between tectonic plates, long ancient rift zones, and buried faults that haven't shifted since before your great-great-grandparents were born. It doesn't creak. It doesn't groan. It simply waits. Imagine two massive slabs of crust pressing against each other. Neither wants to move. The friction is enormous. But every year, perhaps only a few millimeters at a time, they try. That tiny shift adds energy, and that energy has nowhere to go. At first, the rock absorbs it. Rock can bend, believe it or not. Like cold glass, it can deform under immense force. It changes shape slightly, holds the strain, tries to be patient. But all materials have a limit. And, eventually, sometimes suddenly, sometimes with no warning at all, that rock snaps. It breaks along an existing weakness, or it creates a new one. And when it does, the pressure is released in a jolt. That jolt is what we call an earthquake. But by then, the pressure has already done its job. It is built up quietly, invisibly, beneath homes and cities, forests and highways, till it could no longer be contained. It's strange to think that what we perceive as noise, the rumble of an earthquake, is born entirely out of silence. That something as loud as the earth shifting can come from something that made no sound until the moment it broke. And so, when you think of seismic risk, don't think of dramatic cliffs or boiling springs. Think of pressure. Think of long years of stillness. Think of what builds when nothing appears to be happening. Pressure is most dangerous when it's ignored. In the eastern half of the United States, where earthquakes are less frequent and less visible, this pressure is often forgotten. The ground feels still. The soil is thick with memory glacial deposits, ancient sediments, rich farmland. It hides the scars of older quakes under centuries of erosion, but the faults are still there, and the pressure hasn't gone away. In fact, in some ways, it's worse, because older faults like those in the New Madrid seismic zone or the Charleston fault in South Carolina are often less well mapped. They may be buried deep under layers of silt and rock. We don't always know where they are until they move. Again, and unlike the faults in California, where the Earth's boundaries are defined by obvious cracks and ongoing motion, these mid-continental faults are more mysterious. Their motion is less predictable. Their behavior is not part of a regular rhythm that makes their pressure all the more ominous in places like Missouri, Arkansas, Kentucky, and Tennessee. GPS instruments show that the ground is still shifting ever so slightly. B rate is slow millimeters per year, barely a crawl. But multiply that crawl by decades, by centuries, and it becomes measurable stress. And the more stress, the more likely it is that something will slip. But again, pressure does not knock on your door. It doesn't shimmer like heat waves or roll like thunder. It doesn't ripple across the surface like a wind through tall grass. Just remains beneath your feet, patient, relentless. It's easy to forget this as you go about your day. You cook, you drive, check the forecast and plan for storms. You prepare for winter and summer. But who prepares for silence? Who plans for the slow tightening of the planet's skin? There's something poetic and unsettling about that the earth is not loud until it absolutely must be, that its greatest threats may come from the quietest places, and that pressure, by its very nature, gives no warning. Of course, scientists try. They install seismometers, okay? They measure strain with laser instruments, okay? They model fault behavior on supercomputers, but predicting when a fault will slip remains one of the most difficult problems in geology, because pressure is not linear. It doesn't build like a calendar. It doesn't follow the neat schedule of a machine. It is influenced by moisture, by rock type, by geometry deep underground that we cannot see. Some faults can hold more strain than others. Some slip gradually in what's called creep. Others hold perfectly still for 500 years, then release everything at once. We still don't fully understand why, and so our best defense is awareness, not fear, not obsession, just a quiet acknowledgement that not all danger is loud. Some of it hums beneath us, unnoticed, until it becomes too much to bear. You can prepare for an earthquake without panicking, just as you might install a smoke detector without expecting a fire. It's not about prediction, it's about wisdom, reverence for what you cannot control. In Japan, school children learn to brace under desks during drills. In California, buildings sway gently instead of collapsing, thanks to engineering that anticipates motion. In the central U.S., where pressure hides under crops and rivers, the need for preparation is just as important, even if it's easier to forget that, because the earth does not forget. It records stress in rock, in buried sand layers, in old faults that haven't moved in 100 generations. It remembers every pressure point, every fracture, every release, and sometimes, when it's ready, it remembers out loud. So tonight, as you lie in bed, you may feel still. The walls are steady, the wind is soft, the air is cool. Up below you, the planet holds its breath, not to frighten you, not to threaten, but because this is what Earth does. It carries pressure quietly till it doesn't. And in that knowledge, there is something strangely comforting. The reminder that we are part of a system older and deeper than we can see, that we live not on top of the earth but within it, in partnership with its rhythms, both loud and silent. So sleep softly tonight, knowing that pressure may have no voice, but you are listening anyway. Stillness is one of the most comforting illusions the earth offers. You look around at the trees, the hills, the buildings, the vast spread of horizon, and everything seems steady, solid, unchanging. The ground doesn't ripple beneath your feet. The air is calm. The seasons pass as expected, and in the silence, you are led to believe that nothing significant is happening underneath. But this, as it turns out, is the most convincing act of geological theater. Because beneath the illusion of calm, the crust is never at rest. It merely wears a mask of composure. This illusion is most powerful in places where earthquakes are rare. Take the central and eastern United States, for instance. These regions are often described as seismically stable compared to the West Coast. There are no towering fault lines slicing through the landscape, no boiling geysers or rumbling geothermal vents, no dramatic uplifted ranges or twisted coastlines. The landscape is modest flatlands, rivers, forests, rolling hills, and because it lacks drama, it appears safe. We measure seismic risk and probabilities in colored maps, a soft green, maybe yellow, and we tell ourselves, the risk here is low. The chance of a big quake is small, and the longer nothing happens, the more confident we feel. We begin to interpret the absence of motion as the absence of danger. But geologists know the quietest places can hold the deepest secrets. In these regions, the crust is older, it's colder, thicker, and more rigid than the thin, hot, shifting plates of the Pacific edge. That rigidity doesn't prevent earthquakes, it just changes how they behave. When stress builds here, it doesn't always release in small, helpful doses. There may be no foreshocks, no frequent tremors to relieve pressure gradually. Instead, the strain builds quietly for decades, even centuries, and when it finally gives, it may do so all at once. That's why scientists speak cautiously about inactivity, because geologic time moves differently than human time. 100 years without movement means nothing to a fault line that sleeps for 1,000. A generation may live and die in complete calm, never knowing that the earth is flexing slowly beneath their homes. Let's pause and imagine this. A farmer in Missouri walks his fields, day after day, year after year. The soil is rich, the weather patterns familiar. No earthquake has disturbed his land in his lifetime or his father's. His house has stood solid for half a century. His town has no seismic codes. Why would it? The ground has always been still. But 150 miles beneath his boots, tectonic stresses persist. Ancient faults from long-forgotten rifting events when the continent nearly tore itself. Parts remain etched into the base of the crust. These faults are buried beneath miles of sediment. They're invisible, even to satellite imagery, and yet their memory is intact. This farmer doesn't know it, but he lives atop the same geological scar that once produced one of the most powerful earthquakes in American history, the New Madrid earthquakes of 1811 and 1812. These quakes, centered in the middle of the continent, were so strong that they rang church bells in Boston, over 1,000 miles away. They reshaped the Mississippi River, caused landslides, liquefied soil, and created new lakes. And then after weeks of violent activity, the fault went silent again, so silent that by the early 20th century, many believed it was gone for good. But faults don't disappear. They just rest. And silence, when it comes to earthquakes, is not peace, it's potential. The illusion of inactivity affects not only individuals, but cities, institutions, and infrastructure. When nothing happens for a long time, we forget to prepare. We build without seismic resistance. We design bridges and pipelines under the assumption of permanent stillness. Hospitals, schools, water lines are laid out as if the earth beneath them were frozen in place. But earth does not freeze. Even now, small movements are detectable in the New Madrid zone. Subtle shifts millimeters per year continue. Not enough to notice, not enough to frighten, but enough to remind those paying attention that the fault is not done. Elsewhere, the same illusion plays out. In the Carolinas, there are buried faults. Near Charleston, the site of another devastating quake in 1886, most residents don't know it happened. The buildings there are mostly unreinforced masonry. The city is more famous for its architecture than for its seismic history. But again, the silence of recent decades has masked the memory of that trembling past. In Illinois, Arkansas, Indiana states, rarely associated with seismic danger, evidence of past quakes is etched into the landscape if you know where to look. Sand blows, displaced riverbeds, subtle shifts in tree lines. But these traces are not dramatic. They don't make headlines. They whisper, and in the noise of daily life, we do not always hear whispers. So, what do we do with this knowledge? How do we live in a place that seems still but isn't? How do we reconcile the comfort of the present with the uncertainty of the deep past and the deep future? The answer lies not in fear, but in awareness. We must learn to see stillness as incomplete, to question quiet, to recognize that an uneventful history is not a guarantee of an uneventful future. Preparedness doesn't mean panic. It means humility. It means looking at a green spot on a seismic risk map and asking not, am I safe, but am I ready? Because readiness can coexist with calm. Just as engineers design for 100-year floods or storms that only come once in a generation, they must also build for quakes that may not happen tomorrow, but still might in California. This awareness is built into daily life. Earthquake drills, flexible structures, reinforced foundations. But in quieter parts of the country, the illusion of inactivity has dulled the sense of urgency, which is why stories matter. We must tell the stories of past quakes like New Madrid, like Charleston, not as distant anomalies, but as reminders of the long game the Earth is playing. We must study the slow creep of strain, even when no one feels it. We must listen to what the rocks are saying, even when they seem silent, because inactivity, in the Earth's language, is not the same as peace. It's simply a pause, and pauses end. Let's return to that farmer in Missouri, watching the sun set over his fields. He feels safe. The land feels timeless. But 30 miles beneath him, the mantle is nudging against the crust. Tiny shifts, tiny tensions. Movements far too small for any human to detect. But the earth remembers, and eventually it speaks. Maybe not tomorrow, maybe not for a century. But silence, by nature, is temporary. So we must live with our eyes open, our ears tuned, not afraid, but attentive. Not fearful, but respectful. The illusion of inactivity will always exist, is how the earth hides its stories. But we are learning to read those stories in new ways, through seismology, through soil, through the slow, quiet art of listening. And in listening, we find balance. We prepare, we adapt, we watch the still land, not with suspicion, but with reverence, because the earth is alive, even when it looks asleep. Silence is not the absence of sound, right? It's the presence of something waiting. And beneath the ground, silence holds stories older than speech. But how do you listen to the earth when it doesn't speak in words? How do you hear a whisper through rock? This is the patient work of seismologists, those who place stethoscopes against the earth's chest and wait, quietly, for the rhythms beneath to stir. They are not fortune tellers. They do not claim to predict. What they do instead is listen. They listen with tools, with maps, with algorithms, and with time. Time is essential because the earth reveals itself slowly. Quakes are dramatic, yes, but most of the life of a fault happens in silence. And so, scientists begin where silence lives deepest beneath our feet. The tools they use are not made for the impatient. Seismometer, for example, is exquisitely sensitive. It does not wait for a dramatic quake to stir. It listens, always. It listens to footsteps in a hallway, to ocean waves crashing hundreds of miles away, Ks to subway cars in distant cities, even to the soft shifting of tree roots under frozen soil. These instruments don't just detect movement, they document it. Every wobble, every hum, every pulse that passes through the Earth's crust is etched into data. A seismometer might record hundreds of tiny events a day. Most are harmless. Many are from human activity, fracking, blasting, drilling, or construction, but buried within the noise. Scientists learn to recognize the signature of something deeper. The Earth's natural rhythms are like a song you've heard before. There are bass lines and crescendos. There are quiet, rumbling notes, low frequency, tremors that might last minutes. And then there are the sudden jolts, like sharp cracks in the melody. These could be earthquakes, or not. The key is context. That's why networks are important. A cross-seismometer listens alone. Across the USC van in the quietest regions, you'll find a hidden orchestra of listening posts. Some are embedded deep in the soil. Others are nestled into mountain ranges. Some float in the ocean on buoys, feeling tremors in the sea floor. Together, they form a kind of auditory map of the continent's underworld. When the earth so much as twitches, these stations take note, and when enough of them take note at once, picture begins to form. But the work doesn't stop at detection. Seismologists also measure something called strains, a slow buildup of pressure in the Earth's crust. Imagine taking a thick rubber band and stretching it. It doesn't snap right away. It resists. But if you stretch it far enough, long enough, it suddenly breaks. The same is true for faults. To track strain, scientists use tools like GPS stations, but not the GPS in your phone. These are far more precise. It can detect movement as small as a millimeter. Over months or years, they show how land is shifting, not in dramatic jolts, but in a slow, tectonic creep. A hillside might be inching eastward. A valley floor might be bulging ever so slightly. You wouldn't notice, but the sensors do. And, over time, they reveal stress building where it wasn't before. Sometimes, this buildup is part of a natural cycle release will come, but not as disaster. Other times, it's a warning. But even then, warnings are never absolute. The Earth doesn't speak in guarantees. That's why seismologists are cautious with language. They speak in probabilities, not predictions. They say there is a 5% chance of a large quake in this region over the next 20 years. Not a quake will strike next week. Okay? While this uncertainty may frustrate some, it reflects a deep humility and understanding, okay, that we are listening to a force far larger than ourselves. Some scientists go even deeper. They use underground boreholes, then drilled tunnels that go miles into the crust. There, they install strain meters, tilt meters, and temperature sensors. These instruments sense how rock flexes, how fluids move, how pressure shifts with the seasons. You wouldn't think the Earth breathes, but it does. It swells slightly with rainfall, contracts in drought, pulses with tides and moon cycles, all of it recorded, all of it meaningful. And then there's the newest frontier, machine learning. Thousands of hours of seismic data are now being fed into algorithms trained to recognize patterns that the human eye might miss. It's like teaching a computer to recognize the sound of a particular bird in a rainforest full of noise. After years of listening, the machines can say, this vibration is normal. This one is not. Sometimes they identify slow earthquakes. Strange kind of quake that doesn't jerk, but slides. These can last days or weeks. They don't cause much shaking on the surface, but they release massive energy underground. Some scientists believe these may be precursors to larger quakes. Others think they're safety valves. Either way, they're important clues in quieter parts of the U.S. like the Central Plains or parts of the South. These techniques are beginning to unearth hidden fault lines. Places that haven't quaked in centuries are revealing signs of ancient rifts. Buried faults that once tore the land are now detectable, not through shaking, but through subtle bends in sediment layers. Satellite imagery helps. LiDAR scans lasers that map the surface with extraordinary precision. In some places, LiDAR has revealed ghost traces of past earthquakes, uplifted ridges, displaced stream beds, even buried scarps cliffs created in a single jolt. Now hidden under centuries of soil and forest, these are not just academic discoveries. They change how we build, how we plan, how we sleep. Knowing that a city sits atop a sleeping fault, one previously unmarked, can shift zoning laws. It can lead to retrofitting bridges, reinforcing hospitals, altering evacuation plans. Okay? The listening, in other words, leads to life-saving action. And yet, the work is slow, it's painstaking, it's often unglamorous. There is no red alarm when a strain meter twitches, no headline when a GPS station slides by half a millimeter. Most of this research happens in quiet rooms, with glowing screens, spreadsheets, static. But it matters, because the Earth's language is not spoken, it is recorded, and those who listen must do so with reverence. Still, listening isn't just about rock and pressure. Scientists also listen to the stories of people, okay, indigenous communities. For instance, often remember earthquakes in oral history. In Alaska, in Missouri, in the Pacific Northwest, tribes have long passed down tales of land that shook, rivers that reversed, oceans that disappeared and returned in massive waves. These stories may sound mythic, but they often align with geological records, tsunami deposits, sand layers, drowned forests. And when science listens to history, patterns emerge, Even animals may be part of this story. In the moments before earthquakes, some animals behave strangely. Dogs whine, birds take flight, snakes slither from burrows. Scientists aren't sure why. It may be that animals sense low-frequency vibrations or changes in magnetic fields, or perhaps shifts in groundwater chemistry. It's not a reliable prediction, but it is another whisper, another piece of the puzzle. All of it contributes to a fuller picture, and in the quietest parts of the country, those painted soft green on risk maps. This kind of listening may be the only warning we get, because these regions will not announce their intentions. They will not rumble with foreshocks. They will not tremble with microquakes. They will simply shift once, suddenly, massively, unless we listen. And so, tonight, as the world quiets, know that beneath the stillness, there are instruments humming, scientists watching, machines learning. The earth continues its slow conversations, and we, at last, have begun to understand its grammar. It doesn't shout, it hums, and in that hum, everything is revealed. When nothing happens for a long time, people forget. They build homes, cities, and memories atop the silence, mistaking stillness for safety. They walk barefoot across cool floors in kitchens, unaware of the quiet tension miles below. They plant trees, raise children, sleep soundly, and over the years, the silence begins to feel permanent. But silence, the language of the earth, is never absolute. It is a pause, a breath held in rock. The crust of the earth does not stop moving just because it stops shaking. In fact, when nothing happens for a long time, it often means that something deep and imperceptible is quietly preparing. Geologists call this strain accumulation. You could call it waiting. Picture two pieces of Earth's crust, side by side, locked at a fault. They want to move, pulled by the motion of the tectonic plates they sit on. But friction keeps them stuck, so they push, slowly, relentlessly. Neither yields. Over years, then decades, then centuries, the strain grows. It is like bending a thick piece of wood. You can't see the crack forming, but inside, fibers stretch, tiny fractures open. The whole piece becomes more and more fragile until, one day, with no warning, it breaks. The longer the silence, the more dramatic the release. This is what scientists know about certain areas of the United States. Areas where the land hasn't moved in hundreds of years, at least not in ways we can feel. These are the quiet zones, the mid-continent faults, the intraplate mysteries. They lull us into comfort because they do not behave like the West Coast faults. California's San Andreas Fault, for example, shudders often, little quakes, frequent whispers. It reminds everyone that it's alive. But in places like the Mississippi Valley, or the Deep South, or stretches of the Midwest, the ground barely whispers. The last major event may have happened when your ancestors were still farmers or pioneers, or before the first train ever passed through, or long before any written record. And so the quiet stretches longer. 1 year, then 10, then 50. The people forget. They build denser cities, lay water pipes and fiber optic cables, construct overpasses and levees. They look at the ground beneath them as stable, not realizing that even now, that ground is coiled tight with stored energy, a kind of geologic potential, biding its time. Scientists see it in soil layers. They see it in the sediment that suddenly ends in sharp shears, suggesting it was violently cut and shifted. They see it in trees tilted at odd angles, ancient lakes formed from land subsidence, and buried fault scarps no one noticed before LiDAR imaging scanned the surface. The clues are there, but the longer the time between events, the harder they are to find. People ask, if there hasn't been an earthquake here in 200 years, why worry now? But that's exactly why. Earthquakes on intraplate faults, those deep in the interiors of continents, are rare. That's true, but when they strike, they're often more devastating than coastal quakes of equal magnitude. Why? Because the rock is older, colder, and less broken up. It transmits seismic waves more efficiently. A quake that might shake 30 miles of coastline in California could rattle 300 miles of farmland in Illinois or Tennessee. The shaking travels farther, reaches more people, affects more infrastructure, and most of these places are not built with earthquakes in mind. Building codes are looser. Structures are more brittle. Bridges may not sway with the ground, they may crumble. Pipelines may rupture. Electrical grids may flicker and fail. It's not fear-mongering. It's history. Take the New Madrid seismic zone. For instance, from December 1811 to February 1812, a series of massive quakes struck near New Madrid, Missouri. They rang church bells in Boston. They caused the Mississippi River to flow backward twice. Entire forests sank into liquefaction. Ground fissures swallowed roads. The earth moaned for months. It was one of the most powerful seismic events in U.S. history. Yet most Americans have never heard of it. Why? Because it didn't happen near a coast. Because it didn't repeat in our lifetimes. Because no photographs were taken. No reporters chronicled it. Just a few journals, a few survivors, and then silence. The area has been mostly quiet ever since. Small tremors. Yes, but nothing close to the scale of those early 19th century quakes. But strain continues to build. Scientists monitor this with GPS arrays. They track the land's subtle movement shifts, too small for humans to feel. Some areas appear to be inching westward. Others rise or sink by millimeters per year. It's not dramatic, but it's measurable. And when you measure movement over 200 years, even millimeters add up. Still, the quiet continues. And in that quiet, human memory fades. Emergency drills stop. Insurance coverage lapses. Preparedness budgets shrink. Politicians turn their focus to more immediate concerns. And slowly, inch by inch, an entire region forgets it lives atop a sleeping fault. This is not unique to the U.S. Japan, too, has regions that were quiet for centuries until they weren't. The same goes for India, China, Turkey. Earthquakes are not random, but neither are they predictable in the ways we'd like. Geologists speak of recurrence intervals, the average time between large quakes on a given fault, but these are averages, not schedules. A fault with a 500-year recurrence may quake tomorrow or not for another 200 years, when nothing happens for a long time. It's easy to imagine nothing ever will again, but nature doesn't work that way. A forest may go decades without fire. That doesn't mean it isn't dry. That doesn't mean it's not ready to burn. It just means the next spark will have more fuel. The same goes for faults, and the next rupture will be shaped not only by geology, but by us, by what we've built, by what we've forgotten, by how much trust we've placed in the silence. So, what can be done? Education helps. Quietly, without alarm, communities can learn the history beneath their homes. They can teach students that earthquakes are not just a West Coast story, that rivers don't bend themselves, that plate tectonics may sleep, but never die. Local governments can invest in retrofitting infrastructure, not as an emergency act, but as quiet stewardship. Planners can avoid building hospitals or data centers on known fault zones. Water systems can be reinforced. Early warning systems, where possible, can be installed not because disaster is certain, but because readiness is wise. And above all, people can learn to listen because the land remembers, even if we don't. And the longer it stays silent, the more we should wonder what it's waiting for. But tonight, the ground is quiet. There are no sirens, no quakes, only the slow, deep ticking of Earth's internal clock, too slow for ears, too large for eyes. too large for eyes, but they're all the same. You sleep beneath this stillness. Let it hold you. Let it teach you. And perhaps, as you drift, you will feel not fear but respect. Respect for the long breath the land is taking, and the day it will exhale. Not all danger wears a name. Not every fault line is drawn neatly on a map, announced by jagged mountains or steaming vents. Some lie deep beneath soft plains, shielded by sediment and centuries. They sleep so soundly, even the birds overhead forget they ever stirred. These are the hidden faults, and they carry the oldest risks of all. The earth is a layered memory. Sandstone, shale, clay, limestone, each a page in the planet's slow autobiography. But sometimes, when we read these layers carefully, we find interruptions. Disruptions in the grain, ripples in the structure, angles that do not belong, a shift, a slip, a scar that runs diagonally through time. This is how geologists discover faults we never knew existed, not by seeing, but by sensing, listening, by digging, by letting the soil confess its secrets. In much of the American Midwest and South, the land appears flat and quiet. Fields stretch endlessly toward the horizon. Corn and cotton, soy and wheat, barns rise clean and square. Storm clouds are the only drama, but beneath the roots, some of the oldest faults in North America remain buried, veiled by tens of meters of sediment. They have names, sometimes like the Reelfoot Fault, the Mears Fault, or the Charleston Seismic Zone, but many remain nameless, unmapped, forgotten. The earth remembers them. So do the few scientists who spent their careers uncovering what others overlook. They search riverbanks where recent floods have exposed bare rock. They measure the tilt of ancient trees. They use ground-penetrating radar and LiDAR, sending whispers into the soil and waiting for echoes. In the Mississippi embayment, they've traced earthquake scars from thousands of years, lines of disruption that span miles. It's hidden beneath fertile floodplain, and what these discoveries suggest is humbling. There are more faults than we thought. That many are ancient remnants from when North America was part of a different supercontinent altogether. Back when Pangea cracked apart and the crust stretched and thinned, leaving invisible weaknesses behind. These aren't the dramatic, well-behaved faults of geology textbooks. They're relics, quiet, reclusive, but capable, still, of violence. Most days, they don't move. Most years, they don't stir. Most centuries, they don't speak at all. But they are not gone. They are simply patient. In Charleston, South Carolina, in 1886, an earthquake shattered the illusion of safety. This was a genteel city, no volcanoes, no jagged cliffs. One summer evening, the ground shook violently. Buildings collapsed. Chimneys crumbled. Church bells fell from steeples. The quake is estimated to have reached magnitude 7.0. It struck without warning, and it changed how we think about where earthquakes can happen. Still, the memory faded, as they always do. By the time the 20th century arrived, most people considered it a freak event, an outlier, a once-lifetime tremor that would never return. But the fault is still there, hidden beneath homes and highways. It hasn't moved since. But the quiet does not mean it's healed. It means it's storing energy again. In Oklahoma, something stranger happened. For much of the 20th century, the state was nearly earthquake-free. But around 2009, tremors began small, at first, then larger. In 2011, a magnitude 5.6 quake struck near Prague, Oklahoma, damaging homes and roads. Geologists investigated. What they found was not a new fault, but old ones wakened. This time, the culprit was not tectonic plates, but human activity. Wastewater from oil and gas drilling had been injected deep into the ground, changing the pressures, lubricating old fault lines. Motion. The earth shifted, This was a reminder. Faults do not need to be young to move. They do not need to look dangerous. They only need the right pressure, the right nudge. And so, even in places where no one expected earthquakes, they began again. But perhaps the most mysterious of all remained those buried in soft sediment, those covered by hundreds of feet of clay and loam, where cities now stand. In these places, the danger is doubly invisible. Not only are the faults hidden, but their effects are amplified. Soft sediment acts like a drum. When seismic waves pass through, they slow and swell. The shaking becomes more intense. Structures sway longer. Buildings designed for solid rock may fail, and yet, because no earthquake has happened there in living memory, no one prepares. Insurance is rare. Emergency drills are absent. Hospitals are not reinforced. And so, the forgotten faults pose a paradox. They are the least studied, but may one day be the most costly. Even geologists speak with caution. There are zones we simply haven't mapped yet. They say zones with all the right conditions, all the right pressures, but no recent activity. In some places, satellite imagery has revealed subtle landwarp lines that suggest slow uplift or subsidence. These aren't active faults, necessarily, but they are suspect. Some sit beneath major cities, St. Louis, Memphis, Little Rock, Cincinnati, even Chicago though. Far from known faults, lies atop ancient rift steep scars from when the continent stretched long ago. If reactivated, even slightly, they could cause damage no one expects. And because these risks are quiet, they are often ignored, but not by everyone across the country. A small community of researchers works quietly, patiently. They gather funding for trench studies. They analyze pollen trapped in ancient soil layers to date past quakes. They map anomalies in GPS data areas where the ground is moving, ever so slightly. Year after year, their goal is not to predict the next quake. That's not possible. Not yet. Their goal is to see the land more clearly, to remember what the ground has already done, to help the rest of us see that stillness is not the same as safety. It's important to say, not all hidden faults will rupture. Some may sleep forever, but some won't. And because we don't know which is which, we must listen to the soil, to the satellite, to the old journals and the trench walls and the tilted fence posts, to the memory that lives beneath our feet. Sometimes it whispers, and sometimes in the stillest places it waits. The risk is not in what we see, it's in what we've forgotten how to look for. And as you lay here, resting, you are held by the land. A land layered in stories, most of them silent. You are safe. For now, the earth moves slowly, but its memory is vast, and even the quietest fault never truly forgets how to move. Let that thought be gentle, not frightening. Let it remind you that everything, even stone, is alive in time. That what rests now has stirred before, and one day may stir again, but not tonight. Tonight, the earth is still, and so are you. You do not need to live near a fault line to feel the touch of earthquakes. Sometimes, long after the shaking has stopped, the earth carries the memory in quiet ways, carried into landscapes, whispered through the course of water. There are rivers today that do not flow the way they once did, not because of erosion. It's not because of human dams or redirection, but because the ground itself moved beneath them. What once trickled south began to roll north. What was once wide became narrow, and in some places, water pooled where there had never been a lake before. Long ago, in the early hours of a cold December day in 1811, something shifted deep beneath what is now Missouri. There were no smartphones, no radar systems, no warning. Sirens only, trees creaking, and animals bolting before the ground began to rise and fall like the surface of the sea. Church bells rang hundreds of miles away. Chimneys cracked in Cincinnati and in the Mississippi River. Something even stranger happened. The water reversed. Eyewitnesses near the riverbanks described waves rolling backwards, surging upstream against gravity, as if the river had forgotten which way to flow. Boats were lifted and tossed onto land. Sandbars vanished. Entire stretches of the river deepened overnight. It seemed impossible, mythic, and yet it happened. The cause: a series of powerful earthquakes along the New Madrid seismic zone fault system in the central United States. Far from the well-known danger zones along the coasts, the New Madrid quakes of 1.811, 1.812 remain some of the most powerful seismic events in American history. They occurred in an area most people had assumed was geologically quiet. But the earth does not follow assumptions. Beneath the flat fields and gentle hills of the Midwest lies an ancient scar, one that awakened for a brief, terrible moment, and then went silent again. And though the quakes lasted only a few minutes at a time, the effects lingered for centuries, none more poetic or profound than what happened to the Mississippi. You see, rivers are shaped by gravity, yes, but they are also shaped by terrain. If the land tilts, even slightly, the water responds. And during the New Madrid quakes, the land did not simply shake, it warped. Large portions of the ground subsided, meaning they sank. Other areas uplifted. It was not dramatic in the way of mountains forming or valleys cracking open, but the subtle topographical changes were enough to reroute one of the greatest rivers on the continent. At least for a moment, in some areas, the riverbed lifted several feet. In others, the banks slumped inward, pulling trees and soil into the water. Entire sand ridges collapsed. Tributaries clogged. Backwater lakes formed places where water suddenly had nowhere else to go. Reelfoot Lake in Tennessee is one such body of water. It did not exist before 1811. The quake made it. Imagine standing in a forested lowland, the soil firm beneath your boots, hand in the space of a single night, that same ground becomes a swamp. A lake emerges where there was none. Trees still grow from the water, their roots buried beneath a new, unintended flood. The land has rewritten its own story, and it is not just the Mississippi. All around the world, ancient quakes have left similar signatures. In Japan, the Great Tohoku earthquake of 2011 caused parts of the coastline to drop by over 2 feet. Rivers near the coast shifted course slightly, not dramatically, but enough to remind engineers that maps, however precise, are only temporary truths. In Alaska, the Good Friday earthquake of 1964 created tsunamis, of course, but also altered the landscape of river deltas. Streams that once flowed gently into the sea found themselves blocked by raised ground or diverted into new channels. In one small village, the cemetery, once safely inland, became a marsh dot, and in China, ancient texts speak of great rivers changing course after quakes. The records are vague, filled with poetic descriptions, like the water fled from the mountain or the river chose a new path overnight. Whether these were metaphors or literal observations, it's hard to say. But history holds many such tales, because water, though strong, is sensitive. It adapts to the land it touches. If the land shifts, so does the flow. Even small tremors can alter underground aquifers. Wells that once gave sweet water go dry. Others begin to taste of minerals. In earthquake zones, this is not uncommon. The pressure below changes, forcing water to seek new routes, sometimes deeper, sometimes upward. It is not violent. It is not dramatic. But it is persistent. And so, over the decades and centuries, rivers remember. They carry within their bends and turns the evidence of movement far below. Strangely sharp curve, a sudden widening, split where there should be one stream. These are clues. And geologists, like readers of old books, trace the lines and try to hear the story. But the earth does not tell its secrets easily, especially in the quiet zones. The New Madrid region today feels peaceful. It is farmland, mostly small towns, long stretches of highway flanked by trees and open fields. There is little, at first glance, to suggest danger. No steaming craters, no jagged cliffs, just flatness, but deep below it, dozens of kilometers down there. Is memory? The fault zone still exists. It hasn't vanished. It merely sleeps, and because the earth works and spans far longer than human lives. What feels like stillness may be only the pause between pages. Some scientists believe the New Madrid seismic zone could rupture again. Maybe not this year, maybe not this century, but the stress continues to build. Satellite measurements show minute shifts. In some places, GPS stations have detected movement of less than a millimeter per year. It's insignificant, perhaps, but not meaningless over time. Even the smallest pressure finds release, and if it comes again, the fault awakens. Reavers may once more reroute themselves. Not dramatically, not all at once, but through 1,000 tiny decisions made by water, reacting to land. A stream that once turned east may bend south. A swamp may become a lake. A town built beside a trickling brook may find itself beside a restless flood. And after the shaking stops, long after the headlines fade, it is the rivers that will carry the memory. They will continue to flow, but differently, as they always have, because in the quiet places, change is slow, but it is deep. It is written not in noise, but in geography, in contour, in how the world holds water. So tonight, as you drift into sleep, think of the rivers, not just as water, but as witnesses. They are old, older than most forests, older than any road. They have felt the tremble of the ground, the lifting of stone, the hush that follows, and even when the earth is silent, they remember. Stillness is comforting. It feels like security, like a promise that nothing is stirring beneath your feet. You step outside on a calm morning, the wind barely brushing the trees, and you imagine the earth is resting too. You drive across long plains, see no mountains or rocky scars, and assume there is nothing there to fear. But the earth does not operate on assumptions. It doesn't speak in volume. In safety, true safety has little to do with silence. In fact, some of the most dangerous places in the world are also the quietest. They do not shake often. They do not roar. Instead, they wait. The New Madrid seismic zone, nestled deep in the heartland of the United States, is one such place. You would not know it driving through Missouri, Tennessee, Kentucky. The terrain is flat. The fields stretch endlessly. There are no signs that the ground once moved with enough force to ring church bells 1,000 miles away. But it did, in the winter of 1811 and into 1812. This quiet zone unleashed some of the most powerful earthquakes in North American history, and then it went back to sleep. Not many remember, and fewer still prepare. Because how do you prepare for something that hasn't stirred in your lifetime, or your parents, or your grandparents? Okay, you begin to believe it won't happen again. But silence is not a guarantee. It is only the pause before the page turns. Consider the nature of seismic activity. The Earth's crust is not a single, unbroken shell. It is a puzzle of massive plates, constantly shifting and grinding against each other. At the boundaries where these plates meet me, find the dramatic, the ring of fire, the San Andreas Fault, the volcanic edges of the Pacific. But faults also lie within plates, hidden, ancient, worn smooth by time, yet still alive. The New Madrid Fault is one such internal fracture. It is not at the edge of a tectonic plate. It is deep within the North American plate, what geologists call an intraplate fault, and it does not behave like others. It doesn't release pressure in regular, predictable intervals. It builds and waits. And then, in a concentrated flurry of events, it reminds the world it exists. After 1811 to 1812, there were aftershocks for decades. People recorded tremors into the late 1800s. Then they stopped. Or rather, they became too faint for people to feel. But that doesn't mean they stopped entirely. Seismometers placed in the region over the past century have picked up hundreds of small quakes, some deep, some shallow, most unnoticed by human senses. A hum. Too low to hear. The danger lies in this low, because when people stop feeling, they stop watching, and when they stop watching, they stop preparing. Towns in the region have grown. Infrastructure has aged. Bridges and dams, many built decades ago, were not designed with major earthquakes in mind. Building codes remain looser than those in California or Alaska. Emergency plans exist, but often gather dust in file drawers. And yet, the U.S. Geological Survey maintains that there is a significant chance of another major earthquake in this region. Perhaps not tomorrow, but the risk is real. Why then is it so easy to ignore? Because quiet is persuasive. The human brain is wired to trust repetition, to believe that what hasn't happened recently won't happen soon. We base our decisions on patterns we can see, feel, remember. But the Earth's patterns are bigger than us. They span centuries, millennia, sometimes longer. Place might remain motionless for hundreds of years, only to rupture with a force that changes the course of rivers and sinks whole towns. The people who lived there may never have felt a single tremor, but their homes were still built on memory, just not human memory. Consider the case of Charleston, South Carolina, in 1886. Long before seismic monitoring was sophisticated, a massive earthquake struck the city. Over 100 people were killed. Buildings crumbled. Cracks opened in the soil. And yet, Charleston was far from any known fault line. No one expected it. It had been too quiet. The same happened in Gujarat, India, 2001, in central China in 1556, in Portugal in 1755. The list is long, and the thread that connects them is simple. Silence was mistaken for safety. There is a quiet psychology to this as well. People prefer predictability. We feel safer when we can point to a map and say, there, that's where the danger is. Fault zones become part of the cultural landscape, like the San Andreas in California or the Cascadia subduction zone in the Pacific Northwest. People build systems around them. Drills, warnings, codes. But when the danger lies somewhere that feels still, feels abstract, it feels like folklore in the Midwest. Many towns have murals, signs, or small plaques that mention the 1811, 1812 quakes, but few treat it as a present-day risk. The event is a story like a ghost tale passed down from great-great-grandparents. It belongs to history, not reality. And yet, the land has not forgotten. Geologists studying the region have found evidence of even earlier quakes long before 1811. Subtle shifts in sediment, patterns in buried tree trunks, disturbances in river. Patzall suggests that the fault awakens every few hundred years, perhaps every 5 or 6 centuries, perhaps longer. We cannot know for certain, and that is the problem. You cannot time an earthquake like a harvest. You cannot schedule it like a storm. There are no seasons, no warning signs that feel reliable enough. Just pressure, invisible, building, waiting. So, what can be done? The answer is not panic. It is never panic. Panic closes doors. It clouds judgment. Instead, the answer is quiet preparation. Engineers in the region have begun to design buildings with seismic loads in mind. Cities have updated bridges, reinforced old infrastructure. Emergency agencies quietly revise plans every few years, just in case. And educators teach children not to fear the earth, but to understand it. They explain that the ground beneath us is not perfectly still, that it shifts, breathes, and occasionally remembers its own strength. They teach that safety is not about predicting every quake. It is about knowing that quakes, like storms, part of nature. You wear a seatbelt not because you expect to crash every time you drive, but because you understand the risk. Earthquake preparation is the same. Not fatalism, not fear, it's quiet readiness. And perhaps that is the lesson buried within these silent zones, that danger does not always roar. It does not always come with flashing lights and sirens. At times, it hides in open plains, in gentle rivers, in soft soil. Sometimes it is the pause that matters, the pause between movements, the space between heartbeats, the hush before a breath. And in that pause, we have a choice to ignore or to notice, to assume safety, or to quietly prepare, to trust silence blindly, or to listen deeper. So tonight, as you settle into bed, think of the quiet places, not as forgotten, but as resting, not as harmless, but as deeply patient. Think of the earth not as a threat, but as a memory keeper. It does not wish to harm, it simply moves, slowly, sometimes suddenly. In between those movements, there is peace, not permanent, but present, just like now. In the human world, we build our lives around prediction. We set alarms, we check the weather, we plan meetings for days that haven't arrived yet. We rely on schedules, timetables, calendar stools that promise control over what's to come. We imagine that, with enough information, we can forecast everything, but the earth does not honor our clocks. It has no deadlines. It moves beneath its own rhythms engine, irregular, and profoundly indifferent to our sense of time. That's why predicting earthquakes, especially those from sleeping giants like intrapolate faults, remains one of science's most stubborn challenges. Despite decades of research, billions of dollars in sensors and models, and immense curiosity, there's still no reliable way to say, here, tomorrow, at 4:12 p.m. The earth doesn't schedule its tremors like that. Instead, it whispers. It hums in frequencies too low for us to hear. It shifts slightly over decades, giving us hints but no guarantees. And in that silence, scientists do their best to listen, not to predict with certainty, but to understand with care. Let's begin with the heart of the challenge, the nature of an earthquake itself. An earthquake is not a thing. It is a release. It's the sudden uncoiling of energy that has been building invisibly within the Earth's crust for months, years, even centuries. Stress accumulates along fault lines, pressing two slabs of rock together with silent force. The rocks resist, strain, bend. They may even deform slightly without breaking. Then, one day, they slip. The energy that was stored in the slow tension is unleashed in a flashing elastic snap, echoing through stone. The ground shakes, waves ripple outward. The rupture becomes an earthquake. But here's the problem. You cannot see that moment coming. You can measure strain, you can map faults, can track tremors, but you can't know when that final grain of pressure will push the system past its tipping point. The rupture is not signaled by a red light or an alarm. It is, quite often, surprise. That's why the most advanced seismologists around the world tend to avoid the word prediction. Instead, they speak of probability. For example, they might say, there is a 40% chance of a magnitude 6.7 or larger earthquake on this fault in the next 30 years. It's not a forecast, it's a statistical estimate, a carefully built model based on past activity, stress measurements, and geological understanding. But it does not and cannot say when. Some people find this frustrating. A countdown clock, a signal to evacuate. And who could blame them? When lives are at stake, ambiguity feels like failure. But in geology, ambiguity is often the truth. Take foreshocks. For instance, those small tremors that sometimes precede a major quake. Not always, just sometimes. A foreshock looks exactly like an ordinary minor earthquake until a bigger one follows. There's no way to tell in real time whether a magnitude 4 tremor is a harmless event or a prelude to something much more serious. Only hindsight provides clarity, and by then, the rupture has already occurred. Scientists have tried earnestly to overcome this. They've built arrays of seismometers along major faults, watching for patterns in the tiniest of quakes. They've analyzed changes in groundwater, gas emissions, even animal behavior. Some claim to notice increased radon gas levels before earthquakes. Others studied electromagnetic anomalies or subtle shifts in the Earth's magnetic field. But again and again, these signals proved inconsistent. What worked once didn't work the next time, or the signals showed up after the quake had already begun, or the change could be explained by something else, like weather, industrial activity, or equipment error. In science, a theory must be repeatable. If it cannot reliably predict outcomes across different situations, it cannot be trusted. And so far, earthquake prediction has failed that test. Still, the search continues, because even imperfect understanding is better than none. One promising area is early warning systems. These don't predict quakes ahead of time, but they detect them quickly, alert people before the shaking reaches them. Here's how it works. When an earthquake begins, it sends out two types of waves, P waves and S waves. P waves are faster, but they cause little damage. S waves are slower, but they bring the shaking and destruction. Seismometers near the epicenter detect the P waves first. If the system is fast enough, it can use those first signals to estimate the quake's location and intensity, then send alerts to people farther away, giving them a few seconds to prepare. In Japan, such systems are already active. In California, the shock alert system sends alerts to smartphones. A warning of even 5 to 10 seconds can be enough to stop trains, shut down elevators, or give people time to duck and cover. But even this is reaction, not prediction. And what about the sleeping faults, the ones that haven't moved in centuries? What do we know about them? Sometimes the best clues lie in the past. Geologists look for paleoseismic evidence signs of ancient earthquakes buried in the landscape. They studied layers of sediment, disrupted soil, deformed tree rings, and fault scarps hidden beneath farmland or forest. Using radiocarbon dating and other methods, they piece together a history of movement. How often the fault slips, how far it moves, how much energy it releases. From this, they create recurrence models. These don't tell us when the next quake will happen, but they suggest how often similar quakes have occurred before. If a fault tends to slip every 500 years, and it's been 490, that may raise concern. But again, it's probability, not certainty. One fault might rupture on schedule. Another may stay quiet for twice its average cycle. A third may surprise everyone, triggered by a complex chain of forces still beyond our understanding. Because the Earth is not a simple machine. It's a living, breathing planet full of nonlinear interactions, layered pressures, and subtle variations in temperature, mineral composition, and tectonic geometry. It behaves like no clock we've ever built. And yet, in the face of this uncertainty, there is wisdom, because prediction is not the only way to prepare. Just as you carry an umbrella, not because it will rain, but because it might so, too we build for earthquakes, not because they're scheduled, but because they're possible. We do not fear the unknown. We study it. We plan for it. We reinforce our schools and hospitals. We educate our children. We run drills. It's not because we know the day, but because readiness brings peace. And maybe that is the deeper lesson, that life, too, is unpredictable. That certainty is rare. That comfort comes not from knowing everything, but from respecting what we do not know. and choosing to be calm anyway. So tonight, as you lie still, think of the earth as it is, vast, patient, slow, a world not ruled by alarms, but by quiet tides of stone. The shaking will come someday, or not, but in this moment, you are safe, you are informed, and you are resting gently atop a mystery that is yet to unfold. The stillest places in the world are not always empty. Sometimes they are simply listening, and sometimes, if you listen back, you begin to notice things that would never show themselves in noise. Out in the quiet parts of the country, the flat plains, the hushed forests, the towns where time moves slowly, there is a kind of wisdom that cannot be rushed. These are not places where sirens scream or horns blare or subways shake the ground. These are places where the wind gets to finish its sentence, and the earth keeps her secrets tucked just beneath the surface. But silence is not safety, and stillness is not sleep. In these places where the earth looks calmest, something ancient sometimes stirs. The quietest places often hide the oldest scars. They are not marked with jagged peaks or lava flows. They are not crowned with volcanoes or bordered by the deep ridges of subduction zones. They are flat, fertile, familiar. And that familiarity makes their quiet all the more dangerous, because when the earth forgets how to shift for long enough, it sometimes remembers all at once. Let's begin in the middle of the United States, not on the West Coast, where the San Andreas Fault marches along the edge like a serrated blade. Not in Alaska, where the Pacific Plate dives beneath the North American one, but in Missouri, in farm country, near a town called New Madrid. You may have never heard of it. It doesn't call attention to itself. The roads are slow, the fields are wide, and the Mississippi River winds gently nearby. But below that quiet surface, the crust tells a very different story. In the winter of 1811 to 1812, something extraordinary happened here. Over the course of just a few months, a series of massive earthquakes shook the central United States. Not one, not two, but three of them, each estimated to be above magnitude 7. In between them, more than 1,000 aftershocks. Some almost as powerful church bells rang in Boston. Chimneys crumbled in Cincinnati. The Mississippi River flowed backward for hours. Entire stretches of land rose or sank. Forests became swamps. Lakes appeared where none had been. And yet this was not the edge of a continent. This was not a boundary zone. It was deep within the plate, and that's what makes it so settling, because the New Madrid seismic zone disquiet. Calmness regionally reminds us that the earth doesn't only move where we expect it to. It moves when and where it decides to. And sometimes the quietest places teach us the hardest lessons. But why does a place like this even have the power to quake? If you could peel back the top layers of soil, past the fields and clay and bedrock, you'd find an old wounded rift that never finished tearing. Roughly 500 million years ago, the crust beneath this part of North America tried to split apart. The land stretched and cracked, but the process stalled. The rift didn't become an ocean. Instead, it healed partially. That failed rift left behind a zone of weakness, a place where the rock was fractured and thinned, a place more vulnerable to strain. And over millions of years, as the continent drifted and shifted, pressure slowly returned to that ancient scar. And in 1811, it broke again, but it did not announce itself. There were no dramatic tremors in the weeks beforehand, no obvious warnings. It simply began, and by the time it ended, more than a quarter of the country had felt it. Today, that region appears quiet again. Small quakes still ripple through it hundreds each year, but most are too weak to feel. The land has gone back to farming, to watching stars, to the slow rhythm of seasons. But the potential remains, and that's why quiet places matter in modern times. Scientists have begun to treat these areas with greater care. They study old logs and journals from the 1800s. They measure changes in elevation. They drill deep cores of sediment and search for buried layers of liquefied soil, a sign of violent past shaking in tree rings. They sometimes find scars, narrow, stressed growth from years when trees tried to survive on tilted ground or waterlogged roots. From these clues, a story emerges, a story of an earth that remembers even when we forget. And from that story, we learn a lesson that can't be taught in noise, that risk doesn't always roar. Sometimes it waits in fields of corn. Another quiet place worth hearing is the Pacific Northwest, home to rain, forest, and another sleeping giant, the Cascadia subduction zone. It runs from Northern California to Vancouver Island, a tectonic boundary where the Juan de Fuca plate dives beneath North America. And while not completely silent, it is unnervingly quiet compared to other major subduction zones. Where are the big quakes? Where is the volcanic roar? For centuries, Cascadia said little. But just over 2 decades ago, scientists discovered something eerie in Japanese records from the year 1700. A ghost tsunami, an immense wave that crashed into Japan with no local earthquake. To explain it, the answer? The earthquake had happened across the ocean. Cascadia, a massive, estimated magnitude 9.0 event, so powerful it sent a wall of water across the Pacific. So quiet in American history, it left no written recognized forests, coastal subsidence, and broken oral traditions among indigenous tribes. And once again, the lesson was clear. Just because a fault is quiet doesn't mean it's harmless. Sometimes it's storing something, waiting in science. This is called seismic potential, the capacity of a fault to generate powerful shaking. Even if it hasn't done so recently, and many of the United States' quietest places have it. The Wasatch Fault in Utah, the Charleston Fault in South Carolina, the Mears Fault in Oklahoma. Each one quiet. 8. Each one studied. Each one capable of awakening. They are reminders that quiet is not the same as calm. So what do we do with this knowledge? How do we live with an earth that doesn't shout its warnings? First, we build with humility. Engineers and architects in these regions are slowly learning to imagine movement, even where none has been felt for decades. They reinforce bridges, update building codes, retrofit schools, not because they know something will happen soon, but because they respect the places that are too quiet. Second, we study deeply. Seismologists keep listening using GPS arrays, satellite data, and new tools that measure strain invisibly accumulating beneath our feet. And finally, we learn to carry this knowledge without fear, because fear thrives in uncertainty. But preparation thrives in quiet awareness. Tonight, as you rest, think of the silence beneath you, not as a threat, but as a story. A long, slow, beautiful story. One told in stone. One whispered over millennia. It may never speak loudly in your lifetime, but it holds lessons that shape how we live, how we build, and how we sleep peacefully in places where the earth has not moved yet. You walk through a city, any city, and see strength. Steel skeletons wrapped in glass, concrete poured and shaped into towers, roads smooth and straight, sidewalks stable underfoot. The illusion is one of permanence, of something finished, something settled. But beneath that illusion, especially in quiet places, lies a simple, unsettling truth. Everything we build rests on something that moves. Not often, not always, but eventually. This chapter is not about disaster. It is about imagination. It is about memory, translated into stone. It is about the delicate task of preparing not for what has happened, but for what might, and in the world of earthquakes. That task is not only difficult, it is essential, because building for what might return means building for silence, for stillness, 4 regions where generations have lived without ever feeling the ground tremble, and where that very stillness lulls communities into believing nothing will ever change until it does. Let us return for a moment to the heart of the United States, to the fields of the Midwest, the small towns, the historic brick buildings that line main streets in Missouri, Arkansas, Tennessee. These towns were not built with earthquakes in mind. Why would they be? They stand far from known danger zones. Their residents feel no tremors. No one tells stories of walls shaking or chandeliers swaying. And yet, scientists know, because of the new Madrid seismic zone, that the potential remains. Quake, like the one in 1811, could return. Not tomorrow, not next year, but perhaps someday. And if it does, the impact would ripple outward like rings. In a pond, bridges could fail. Water lines could break. Historic buildings built with unreinforced masonry could crumble. Roads would split. Tower would falter. And entire regions could become isolated, not because they're far away, but because they were never meant to flex. Building for what might return means imagining that, not fearing it, not predicting it, but including it in cities like Memphis, in St. Louis. Engineers have begun quietly revising their assumptions. They run simulations, not only for wind and rain, but for shaking. They test soil composition. Some soils amplify seismic waves, behaving like bowls of jelly. Buildings on those soils need special attention. Retrofitting becomes a word of the future, and a passed way of preparing old structures to meet unseen forces. Steel rods are inserted into brick walls. Foundations are strengthened. Schools are assessed, because even if the earth never moves again in their lifetimes, the cost of not preparing is too high, and because preparedness in quiet places is not driven by memory, it is driven by trusting the science. And in the slow rhythm of the earth, now across the country, go west, but not all the way to the jagged coast. Stop in Utah. Here, the Wasatch Fault stretches like a spine beneath Salt Lake City and surrounding towns. More than 2 million people live near this fault, most unaware that it has the potential to produce a powerful earthquake. Unlike the San Andreas, which is well known, the Wasatch Fault is a quiet cousin. It last ruptured in a major way over 600 years ago, but scientists know from trench studies and ground-penetrating radar that it is not done. It is paused, and so Utah builds. The state has spent years mapping the fault in detail. New buildings follow updated seismic codes. Old structures, especially unreinforced masonry, are gradually being evaluated, strengthened, or replaced. Some of these efforts are led by government, others by universities, still others by ordinary citizens who have chosen not to wait for shaking to learn. And still, much remains. The cost is high, the urgency invisible, but the lesson remains. Building for what might return means building without the comfort of certainty. In South Carolina, near Charleston, the earth shook once before. In 1886, the city was jolted by a magnitude 6.9 to 7.3 earthquake. Chimneys collapsed, roads cracked. The damage reached as far as Alabama and Ohio. And then, silence. Generations passed. The city grew, and now, like many quiet places, it faces the dilemma of memory. How long is too long to remember? When does preparedness begin to feel like paranoia? These are human questions, but the earth does not answer them. It simply moves when it must, and so Charleston, like others, begins again to prepare. Slowly, quietly, new buildings are designed to sway. Schools are studied for vulnerability. Residents are gently reminded, now and then, that history is not always in the past. The Pacific Northwest tells a slightly different story, because here, potential quake, the one expected from the Cascadia subduction zone, is so immense, so transformative, that it has given rise to a phrase, the big one. It sounds theatrical, but it is scientific. Geologists believe the zone is capable of producing a magnitude 9.0 earthquake, followed by a tsunami that could engulf coastal towns within minutes. And so, Washington, Oregon, and Northern California have taken steps not out of panic, but out of respect. Sirens are tested. Evacuation routes are posted. Vertical evacuation structures buildings designed to withstand waves and provide a K-grounder being built. In schools. Schools are being taught a new language. One of drills in go bags in drop dash, cover dash, hold dash on dot. Because in this quiet place, preparation has become culture. But building for what might return is not only about structures, it is also about systems, about electricity grids designed to flex, not fractured water systems with backups, about hospitals with reinforced meditations and emergency protocols, about communication networks that don't fall silent when the ground moves. In Japan, one of the most earthquake-ready nations, the buildings are only part of the plan. The rest is coordination, practice, redundancy, awareness. Their trains stop instantly when a tremor is detected. Their early warning systems by precious seconds. Their culture includes not just engineering, but readiness. This is what building for what might return really means. It means designing the world to prevent earthquakes, which is impossible, but to live through them with grace, to endure, to adjust, to bend, not break. In the U.S., many of these lessons are being learned slowly. The nation is vast, diverse, and often reactive. But in recent years, the shift has begun. Federal programs now fund seismic retrofits. Universities train engineers in earthquake resilience. New construction in high-risk areas follows stricter codes. Even in quieter places, the seeds of preparation are being planted. And perhaps, in time, they will grow into a new kind of city. One that listens to the ground, stands on. One that learns from stillness. One that honors both the memory of shaking and the possibility of its return. As you lie down tonight, take a moment to feel what lies beneath you, not with fear, not with tension, just awareness. The earth is old. It has its rhythms. Sometimes those rhythms are felt in days or hours. But more often, they are measured in centuries, in layers of sediment, in patterns too slow for us to see. But that does not mean they are gone. They are merely sleeping. And so we build, not because we are afraid, but because we are awake. We are awake. Night settles across the land. The wind quiets, the air cools, and the distant hum of life softens. In this hush, something ancient stirs not in sound, but in presence. Not in motion, but in memory. There are places in the United States, places between the coasts, far from the headlines, where the earth has not moved in living memory. Towns where porches creak, but foundations do not, where dogs sleep on wooden floors and children ride bicycles along quiet streets. These are places that feel still, settled, timeless. But beneath that stillness lies something else, a slow, quiet breath the planet holds beneath its crust. Attention, not malicious, not vengeful, just natural. A memory of the last time it exhaled, and the potential to breathe again. This is not cause for fear. This is a lesson in patience, because just as the sky is not always blue, and rivers are not always still, the earth is not always at rest. What seems silent may be holding something vast. What seems empty may be rich with waiting. And sometimes the quietest ground holds the loudest stories. Imagine lying in a small house near the center of the country. The room is dark. The floor is still. The wind outside rustles leaves, and you feel safe, distant from the fault lines of California, far from the trembling islands of Alaska, far from the volcanic warnings of the Pacific Northwest. But beneath your bed miles, beneath it is not entirely still. Rock grinds against rock. just a little. Plates push, fold, and strain. Faults rest like scars in the bed, rock silent, deep, ancient. You feel none of it, but it is there. This is not the drama of surface quakes, where the world cracks open. This is the slow accumulation of tension. Centuries may pass before that tension speaks again, but speak it may, and that is why silence in geology is not peace. It is merely pause. The new Madrid seismic zone, hidden beneath the fertile soils of Missouri, Tennessee, and Arkansas, is one of the quietest looking and most powerful earthquake zones in North America. There are no towering mountains to warn you, no visible cracks in the ground. The rivers wind lazily through lowlands. Life continues. But in the winter of 1811 and early 1812, this quiet place rumbled so violently that the Mississippi River ran backward. Entire forests sank into the ground. Church bells rang as far away as Boston. Fissures opened. The earth spoke, and then stopped. 2 centuries later, the soil is still. But that does not mean the story has ended. It has only paused. In the language of the earth, time is not counted in years. It is counted in strata, in sediment, in cycles. A human lifetime is barely a whisper in this scale. A century, a heartbeat to the earth. The gap between one great quake and another is no more surprising than the gap between tides. And so, as we go about our days in these seemingly peaceful regions, farming, building, laughing, dreaming, we live atop a page in a long, unfinished story. A story written in rock. A story with long silences between each sentence. A story we only remember when the ground moves. But perhaps we can remember even in the stillness. Perhaps that's what it means to truly live with the earth. Think of the tectonic plates as vast, drifting continents, massive slabs of crust floating atop the mantle, nudging and grinding and colliding over millions of years. These movements shape the very skin of our planet. Mountains are born from these movements. Oceans shift their shape. Volcanoes rise, sleep, and awaken. And yes, earthquakes ripple through cities, fields, and forests, sometimes announce, more often not. The regions we now call quiet are not exempt from this dance. They are simply on a slower beat. They move differently, okay? They release energy less often, but sometimes more violently. They are deep sleepers, and when they stir, the consequences are broad, because in places where shaking is rare, people are less prepared. Buildings are older, unreinforced. Bridges were not built with fault lines in mind, okay? And memories are past. Quakes fade first from conversation, then from policy. But the earth does not forget. Let's return to silence. Silence is not the absence of sound. It is the presence of waiting. And in geology, silence is a signal. It says the energy is not being released. It is being stored. This is why seismologists look not only at where earthquakes have happened, but at where they haven't. They map strain accumulation. They monitor soil layers. They track microquakes, teeny tremors that barely register, but may hint at deeper changes. They do not wait for noise. They listen to the stillness. In Oklahoma, the ground has begun to stir not because of tectonic pressure alone, but due to human activity. The injection of wastewater deep into the ground has, in recent years, caused swarms of small to moderate earthquakes in places that had previously felt none. This teaches us something critical. Even places that feel safe, stable, and quiet are vulnerable. Sometimes nature holds the risk. Other times we introduce it. In either case, the lesson is the same. What lies beneath us is complex, layered, reactive. We cannot see it, but we can choose to respect it. There's a kind of humility that comes from sleeping over a fault line, a quiet acceptance that our sense of control is limited, that the earth, though mostly kind, is never static, that we are guests on its surface, not owners, and that, in time, even the stillest soil may speak again. So what do we do with that knowledge? We prepare gently. We build wisely. Teach our children what to do when the floor shifts, not to frighten them, but to strengthen them. We invest in early warning systems. We retrofit our most vulnerable structures. Remember the places that have shaken before, even if they haven't in our lifetime. We listen, and when we rest, when we lay our heads on pillows and feel the softness of the earth's silence, we do so not with dread, but with reverence. The earth has always moved. It will move again. This is not tragedy, 'tis simply nature. Stillness is not forever, but neither is shaking. And in the space between, we live. Tonight, as you drift off, perhaps in a valley, perhaps in a city, perhaps in a farmhouse, hundreds of miles from any known fault, remember this. The earth beneath you is alive in a very slow way. It is not plotting. It is not threatening. It is simply breathing in a rhythm that we can barely feel. And as it breathes, it carries us. So sleep deeply, sleep gently. Let the silence hold you, and let the hush of the land remind you not of danger, but of wonder. That this world, in all its layers, has room for both stillness and motion. That you are part of a planet's pause. And that, for now, the ground is quiet. Let it be enough. Let it be peace. Let it be sleep. Be sleep.